Hi everybody, this is Gigi from Kauai Community College. In this video, I will be talking about similar figures and proportions. Let's get started. All right, so take a look. These two shapes, the red and the blue. What do you notice? Well, you might be saying something like they are the same shape, but they are different in size. And you are right. That's those two characteristics lead to the definition called similar figures, right? So similar figures have the same shape, but different sizes. And so let's take a look at the red one. That's an equilateral or triangle. And we know the sum of all the angles in a triangle is 180. So each one of them is 60 degrees, right? Because they are the same shape, the blue one, even though the shape is bigger, the angles stay the same because 180 degrees divided by 3 is still 60 degrees. But so what's different? When you say different in size, what's the difference? It's the lengths, right? So the lengths of the corresponding sides are proportional or they have the same ratio. What does that really mean? Well, suppose that is 2 units and this is 3 units. And suppose I call this side X and the other one Y. We can say that the ratio of X to Y is the same as 2 to 3. And that is what we call a proportion. Is that the only proportion you can write? No, as long as you keep the sides corresponding to one another. For example, if I was to write X is to 2, okay, if I write X is to 2, then over on the blue triangle, the corresponding size would be Y is to 3. So X is to 2 is equal to Y is to 3. And that's another proportion you can write. Okay, so similar figures have the same shape but different sizes. And the lengths are corresponding to each other, but the angles are the same. Okay, the corresponding angles are the same. All right, let's take a look at this one. These two right triangles are similar. Find the missing lengths. That means the X and the Y in the pictures there. Okay, so if we write 12 is to 6, that would be the same as 5 is to X. We're going from red to blue and keep the sides corresponding to each other. So 12 is to 6 is the same as 5 is to X. Now, when you have an equation, you can multiply both sides by the same number and the equation still stay balanced, right? So what am I going to multiply both sides by to clean up both of the fractions? Well, I am going to multiply by 6 times X or 6X to both sides. Okay, now let's see what happened. 6 divided by 6 is 1. I have, and then X divided by X is 1 on the right-hand side. So I really have 12X is equal to 30. Now, if you do so many of these, you will notice that that is the same as just what we say cross multiply, meaning 12 times X is 12X, and then 6 times 5 is 30. So that would be the shortcut for the next time you see that instead of multiplying both sides by your least common denominator, okay? So then to keep solving for X, you would say X is 30 divided by 12, which is 2.5. All right, so now let's go find Y. Okay, pause the video if you like write a proportion, cross multiply, and find y. Well, the proportion I'm gonna write is 12 is to 6 is the same as y is to 6.5. So learning from the last time, I can go ahead and cross multiply, cross the equal sign there. So y times 6 is 6y, and then 12 times 6.5 is 78. Therefore, x is 78 divided by 6, which is 13. And that is how you solve proportions. And the proportions in this case come from similar triangles and their corresponding size. Okay? Now, sometimes similar triangles happen in an overlapping manner, and you have to recognize the two triangles. So in this case, I have the big one, the big triangle there, and I'm gonna draw that out, and that would be that red one, that big red triangle. And then we have a small triangle, right triangle right there. So since these are similar, right, same shape, different sizes, let's go and label the size here. That's Z and that's 10. So we will have a proportion. If we wanted to solve for Z, we would write Z is to 10. So I'm going within the red triangle. Z is to 10. Now, if I was going over to the blue, that would be 4 is to 6. So remember, keep the size corresponding to each other, meaning Z is corresponding to 4, right? And 10 is corresponding to 6. All right, now we would cross multiply and get 6Z equals 40, then divided by 6Z is 40 over 6, which is 6 and 2/3 units. Okay, and that's similar right triangles. Now, similar figures doesn't have to be just triangles, right? It could be any polygon, any shape really, as long as they're the same shape, but different in size. All right, so let's look at these two. There's something going on there that's funny. They don't quite look the same, but if you lean your head or turn your head around somehow, you will see that these two really are similar. Okay, now what do I mean by that? I'm gonna go ahead and redraw the smaller shape, but flip it around so that it's in the same orientation as the large one, okay? And I should have that. Then I'm gonna go and label NM is 18, and NP is 6, PQ is 15, right? And then that missing angle Z is corresponding to this angle 115. And remember, since they are of the same size, the corresponding angles are the same. It's just the length of the sides that are proportional. So then Z, as we know, is 115 degrees as well. Okay, so let's go and find the X and the Y. So let's look at corresponding size. I see that 30 is corresponding to 18 and 25 is corresponding to X. So I can write X over 25. X over 25 is the same as 18 over 30. Cross multiply and then divide by 30, X is 15. Okay, let's go find Y. Go ahead and write down a proportion for Y and try it on your own. Pause the video if you need. I see that Y is to 15. Okay, I'm going from here to there. Y is to 15 is the same as 30 is to 18. Cross multiply, divide by 18, Y is 25. And that is how similar figures work. Math is fun. Keep watching.